Hi again, and welcome to the second part of this Tumult Analytics demo, where we will look at more advanced features of the framework. If you missed the first part, click here to catch up. As a reminder, you work for a large public library and you want to address a request from the City Council about the usage of this public library. You want to make sure that you protect the privacy of library members using differential privacy. We looked at the first two questions from the City Council in the first video, so now we'll focus on the last two. The last two, the interesting thing about them is that they combine demographic data, here age, with reading behavior. So we'll need to do things on multiple tables at once. In the process, I'll demonstrate a number of more advanced features of Tumult Analytics. Joins between multiple tables, I just said, zero concentrated differential privacy, flat maps, medians and other advanced aggregations, binning and advanced truncation. This all might sound a bit unfamiliar and scary, but don't worry, I'll explain or briefly mention what each of them is for as I go. Okay, let's go back to our notebook. So the first question we want to answer is, what is the median age of readers of each literary genre? So because the information we need to answer that query is in two separate tables, we will need to load multiple tables in our session, and we'll also use a privacy notion called zero concentrated differential privacy to get a better privacy accuracy trade-off. This is typically what you would want to use to make sure you squeeze as much accuracy and utility as you can from the privacy constraint that you're working with. So this is what a zero concentrated differential privacy budget looks like. It's just different from a pure differential privacy budget, but it's otherwise, from a syntax perspective, very similar. Then we're going to define what we call an identifier space, and this will be used to tell the session that in both tables that we're going to load, here the checkouts table and the members table. So this contains information about which books were borrowed, and this contains information about what are the demographic information about each library member. We want to protect the same thing, add rows with ID, and we want to say to the framework, these two columns are the same thing. These two columns have the same identifier, the same identifier in one corresponds to the member identifier in the other. Okay, so now we have our session loaded, and we say that we want to protect with zero concentrated differential privacy, and so we can proceed in making the query, running the query. So the first difficulty, let me point out that we did demonstrate zero concentrated differential privacy here. As you can see, it's very simple. One complication about the query we want to run is we want to look at each book and find out which genre the book is associated with. But the problem is each book can have multiple genres. Right? The same book can be both historical and maybe a children's book. So what we will do is we will expand the checkout table here to put each genre on its own row using a flat map. Here, this is how it's done. For each row, for each thing in the genre column, plural, we split it using just this Python function here, and we create a bunch of rows that each have a single genre in it. Then we execute this query, but we don't evaluate it. We just create a view with it. So we create in the session an additional private table that contains our checkouts table, except each row has been flattened into a bunch of rows with a single genre in each one. Then, once we have our view, we're going to create a second view joining both tables, the members table containing demographic information and the checkout single genre that we just created here. Okay, so again, we don't actually consume any privacy budget here. We just say creating a view in the session, like an additional data frame that's private. So far, we haven't looked at any of these data frames, so we haven't consumed any budget. Finally, we can select a few genres. And what's happening here? Did I forget to run this? Yes. We can select a few genres and compute the median age of readers of each genre. So here, there's many more genres in our original table, but we're just going to focus on a list of 6 for simplicity. We're going to enforce a maximum number of rows per identifier, just like we did in the previous video, to prevent a single person from counting too much towards the query. Then we're going to use this genres list here to group by this list of genres, and then we're going to compute the median with clamping bounds, so making sure that every single every single value of the age is forced to be between 0 and 100. This is also, similarly to the constraint enforcement above, necessary for differential privacy to work. Finally, we're going to execute that query, evaluate that query with privacy budget here of rho equals 0.1. Again, we're using zero concentrated differential privacy. Here, on the little video, I made the advanced aggregation tick here because I'm demonstrating median, which not every differential privacy platform has. We also have other types of aggregations like arbitrary quantiles, standard deviation, variance, in addition to the most common ones like sum and average and so on. So as you can see, the query takes a little bit of time to run. This is because I'm running this locally, and because Tumult Analytics is built on Spark, the nice thing is it can scale to very, very large data. The not so nice thing is that it takes a little while to run queries on local data, even if it's not, even if the data is not huge. There's still like hundreds of thousands of rows in there. Okay, so we have our result of the query, and we can now plot them with a little bit of matplotlib code to look at the median age per genre, which tells us something, for example, that the median age for children's book is around 9 or 10, while romance is a genre that's read by older types of readers. Not very surprising. Okay, so that's one of the two queries that we wanted to see in this video. The next one is, can we say something a little bit more about how does reading behavior vary with age? So here we're going to do this in two steps. First, we're going to define age groups and put them into bins. So here we decided that we're going to have one bin that's for age between 0 and 20, another one between 20 and 40, 40 and 60, 60 and 80, and 80 and 100. And then we are going to group by both these bins, like the bin's age, the age, but put in these bins, as well as the same genres that we're interested in earlier. So that's demonstrative of binning. And now we can run our query using what we call advanced truncation. So what do I mean by advanced truncation? If we look at the past queries that we run with privacy IDs, we used here max rows per ID to say, for each member of our library, we want to count it for at most 10 rows. However, here we're going to do something a little bit more complicated. We're going to say, for each different value of bin age, how many times this can happen per identifier, and for each value of genre, how many times can this happen per identifier. So here, each person has a single age, and we are only considering 6 genres in our analysis, so we're going to add this sort of constraint enforcement that don't count the number of rows, but that counts the number of groups that can be created from a single identifier. Similarly, for each of these groups, we're going to count how many rows in each group each person can contribute to. So here we only want to count each person once per genre, and which means that in total, each person will appear at most 6 rows. The nice thing about enforcing these constraints in this way is that it increases the privacy accuracy trade-off, especially when using zero concentrated differential privacy. Behind the scenes is going to use Gaussian noise. So it might sound a little bit complicated, but the way you can summarize this is one of the many ways Tumult Analytics has that allows you to squeeze as much utility accuracy as you can from your given privacy constraints on your data. Now query is done executing, so let's look at what it looks like. So here we can see a little bit more fine-grained information about reading preferences per age. Here you can see again that like mostly children read children's book, or the interest in historical books grows with age. Okay, and that concludes our small demo. Let's go back to the presentation. So that concludes the demo. I hope I made you want to try it out. If so, you can go to tumult.dev, where all of the links to the installation instructions, tutorial, the rest of our documentation, and so on are there. And if you have any questions, feedback, support requests, or if you just want to hear about new features as we improve Tumult Analytics over time, please join our Slack server. We're friendly and we don't bite. Have an excellent day. And how are you supposed to end the YouTube video again? Don't forget to like and subscribe.